Okay, so in this problem, Alden's selling some programs for something. I don't know, programs for what? Oh, football game. Anyways, so what happened is he's printing up some programs. It costs 62 cents to print each program. He sold some of them, but he didn't sell all of them. There are 200 unsold programs. So he paid 62 cents each to get them printed. He's going to sell them for 85 cents each. 200 of them didn't sell, and he lost how much money? $78. Okay. We're trying to figure out how many programs he sold. Now we're just going to use a guess and check table as usual, guessing at the thing we're trying to find, shooting for a target. And again, there's lots of different ways to set this up, but this is just one way that made sense to me. So let's just pick, let's say he sold, I don't know, we'll pick 200 programs. I'm going to pull that number out of thin air. At 62 cents each, 200 times 0.62 be $124. See, if he didn't sell, if he had 200 unsold programs, he sold 0. So he brought in 0 money. And that would mean he'd be down $124, but that's not what happened. He was only down 78, so he must have sold some programs. Let's try 300. 300 times 0.62 would give us $186. So he sold 100 programs then. If there were 200 unsold out of 300, he must have sold 100. And that would mean he brought in $85, 85 cents times 100, so 85 minus 186. 85 minus 186 is he lost $101. He's down $101, but he's only down 78, so let's bump it up again. Let's try 400. 400 times 0.62 is $248 that it cost him to print all those programs. If he printed 400, didn't sell 200, he must have sold the other 200 at 85 cents each. That means he'd bring in $170. So 170 minus the 248 is, negative 78. So if he sold 400 programs, it would have cost, or he printed 400 programs, it cost him $248 to print. If he didn't sell 200 of them, then he must have sold the other 200, bringing in at 85 cents each, $170, and 170 take away 248 is the loss of $78. Now, how to set this up as an equation? Well, if I want to call the number of programs x, then this would be, well, all we did was multiply the number of programs by x, so 0.62x. The number of programs he did sell was x, take away the 200 here, so x minus 200. And the revenue from those is just this column times 0.85, so 0.85 x minus 200. And then for the last column over here, well, it's just revenue minus printing costs, or 0.85 x minus 200 minus 0.62x equals P for profit. So if I want to solve for a particular profit, 85 x minus 200 minus 0.62x equals negative 78. So let's see, I'll do a little distributive property here. I get 0.85x minus 170 minus 0.62x equals negative 78. Let's add 170 to each side. Negative 78, plus 170 is 92. 0.85x minus 0.62x. We'll combine like terms. 0.85 minus 0.62 is 0.23. And then we'll just multiply or divide by 0.23 on each side. 0.23, oh, clear. 92 divided by 0.23. Oh, it's 0.92. 92 divided by 0.23, 400. 400 tickets. Oops, 400 tickets printed. So again, we could set up the guess and check table, but if we could think this through without the guess and check table, I think, well, again, you could even set up the guess and check table and then label your column. So if I'm going to guess at number of programs printed, that's going to be X. It's going to cost 62 cents each, so 0.62 times X. Well, how many programs did they sell? Well, the total minus the 200 they didn't sell. And they're going to sell those at 0.85 cents each. So this is our revenue minus our expenses will equal our profit. And then we just set profit to whatever we want, or in this case, or maybe we didn't want, loss of $78 to solve for the number of tickets that we must have printed. And that is all men's tickets.